Good afternoon. Hope everyone's doing well. Welcome to today's webinar. Where we're going to focus on how to get a more accurate CAD model and also reduce costs by running simulation up front. My name is Rob Romanowski. I'm the Director of Sales Operations for 3HTI. Leading our presentation today and demo is Paul Dye, a Solutions Consultant and Applications Engineer with PTC's Virtual Center of Excellence. Paul does a great job for us. And the whole purpose of these tools within the all PTC simulation suite is to give designers and engineers the capability to be able to run an analysis early in the design stage so that as the model goes downstream, you don't have to go back and rework it, because I'm sure that everybody on the call knows that the later you have to change the model, the more challenging it becomes and the more problems it can cause. And if you're relying solely on building prototypes for your simulation purposes, you might want to consider getting this tool and saving a lot of time, money, and resources. So anyway, without further ado, Paul, you have the con. We can see your screen. Take it away.
Awesome. So thank you everybody for hopping on, and happy to be on talking a little bit about Creo Simulate. This is maybe a tool that you've worked with in some capacity in the past, or maybe you've just seen the tab for from within Creo, but very strong capabilities, something like Rob mentioned that we have integrated into really a lot of what we're doing from the design process, not only just in Creo, but just in your overall design, from conceptual into your prototyping and even down the line to manufacturing and validation. There's a bunch of different areas that simulation can really be useful and something that Simulate plays a part in. Right, so I'll go through and explain exactly what we use Creo Simulate for, what some of the capabilities are, go through and show what it looks like in the context of Creo. And when we wrap up, I'll go through and just talk a little bit more about PTC's strategy around simulation. I want to speak to some of the different tools that we have in the space for running simulation and just give a quick breakdown into which area each one's useful in, and then some sort of the direction that we're moving in that sense as well. All right, so just looking at some of the challenges around analysis in general, and the big thing is seen as something that you really do as an FEA or analysis expert, right? You have someone that's dedicated towards doing that type of work, and it's not something that really your designers or engineers are doing a lot, right? As a designer, I'm just making parts, I send them off to the analyst, you tell me if it's going to pass or not. It becomes more of a process of, again, I create the model, ship it off, and you wait to get results back. Or it should be a little bit more of a collaboration, right? So you're not just using it only for validation, you're also able to use simulation as a way to work towards more of an ideal design rather than just a pass or fail. Because if a part simply just passes, right, it's more likely to underperform, cost you more money in the long run. And the other thing that Rob mentioned as well is that a lot of times analysis ends up being done too far along the design process. So you end up being 85, 90, 95% the way done with the design. And if you're on analysis at that point and something fails, well, how much time, how much cost are you going to have to run back through, fix things? It would be a lot better if we could start to incorporate simulation more so into the design process, not only as a check at the very end. So this is something that we've seen time and time again, and really our solution to a lot of these challenges from within Creo is with Creo Simulate. So this is our traditional analysis tool that we use to take the things that we're designing and really start to truly understand the changes that we're making and do that throughout the design process. It includes things like structural, thermal, vibration analysis tools, all these different areas to help us just truly understand how the models are performing, put them under real world conditions. And one of the biggest things here is the fact that it's integrated seamlessly in with Creo Parametric. Same exact user interface. It's just going to be a click away, and really start to change our mindset throughout the design process around simulation. And the idea is that we want to move more so away from just the pass or fail mindset and work more towards finding what the optimal design is and do that throughout the entire design process. One way that we do this is through the ability to run optimization and feasibility studies. But within Creo Simulate is a very strong capability that we use, and something that I'll go through and show a little bit of. So first and foremost, running feasibility studies helps you understand if your design is something that's even possible to get to, right? Is it something that you keep working with? And then if so, what variables, what dimensions, what features could you change to maximize on certain goals that you're looking to get? Maybe you want to maximize on strength, but at the same time, minimize on the weight that it takes you to get there. So what we've really done is build up Simulate more so with the designer in mind, right? We want to make sure that as you're going through and building these things out, you want to understand how they're working and really create the model and know that it's going to be the right design, not something you have to wait until later to confirm on. And really with this in Simulate, you have a very full suite of capabilities. The mature tool that we've built out over the course of really the existence of Creo for everything from structural and thermal studies to everywhere down to large deformations, dynamic, pre-stresses, non-linear. So it really depends on exactly what types of use cases that you want to design around. And I'll break down exactly which areas or which packages around Simulate would help with these specific areas as well.
Hey, Paul.
Mm-hmm.
There's a bit of an echo. So I don't know if it's your sound or if it's me also.
I can check my audio real quick and make sure.
Okay, thank you.
All right.
Thanks,
Awesome.
Paul.
Yeah, perfect. So appreciate that before we go any further around that. So yep, just to wrap back through, again, a lot of different areas that you're simulating from within Creo Simulate, but really a core concept that you work with on any type of analysis is meshing. It's almost like a dirty word that people run into, something that the analyst likes to keep to themselves, that they work with and have an understanding of. And that's fine because Creo is all about automatic meshing. So Creo and the system that we're working from within is able to build out an optimal mesh for you. So you don't have to go through and do that every single time. If you really do want to, you do have the ability to override that, and you can still have full control over the mesh and how it gets built out. But in so many cases, you can really just let Creo Simulate do that work for you. So you can jump right into doing the analysis itself. And this works not only for the geometry that you're using, it can do idealizations for solids, shells, springs, beams, all these different areas. Simulate understands, and it's all built into the setup that you run for your analysis. And again, we want to be able to use those feasibility and optimization studies as well. Do it early and on, often from within the design process. So it's not only just for looking at your late stage prototypes, but even into your alpha designs, right? So the sensitivity studies that you're running can really help you to understand the process. It helps you to figure out what properties, whenever you're changing them around, either have or don't have an effect on the values that you care about. So you can try out a lot of different what if scenarios just to get a better understanding of the product that you're designing or the model itself. And then once you run the studies, there's a lot of functionality when it comes to observing the results. So by default, automatically Simulate will go through and build out templates that give you information, say, on your stress, displacement, a lot of other values that you might be concerned with. And then the results from that point can be output into different reports, many different file formats, Excel, VRML, TIFF, HTML, however you need to get it out. And then from there as well, from right within Creo, you can query on the result values to see exactly what those stress values look like or how exactly the parts are going to deform through different animations. You can right click on the model and see certain points to get specific information on that point of the model. And then you also have a lot of different plots that you can work with to observe and provide to others, detailing maybe how the part's going to perform. So again, all of these things, they've been designed to be easy to work with, easy to share, easy to collaborate with others through that as well. And here, just a quick look at Simulate in of itself, right? There's a couple different flavors of what you'd be using here. So in the base of Creo Parametric, you do get access to, I'll say, a light version of Creo Simulate, where you're able to go through and do your static structural analysis on both parts and assemblies. What this is essentially limited by is the model side and the number of surfaces that you might have in a model that you're able to simulate. So that's something that really I always recommend if you want to go through and try some things out and you just want to understand the interface and run with this on some basic models. Perfectly fine for doing that. And then if you're looking to really do this for any level of production or starting to integrate that into your process, I always recommend moving up to the standard Creo Simulate extension. Takes into account everything that you get in the light version, but you don't have any limitations in terms of the model size. And then you can see it starts to integrate in more capabilities for thermal analysis, idealizations, and then starts to take into account optimization or any type of nonlinear contacts. And then from there, there's some more advanced options that you could work with in the Simulate Advanced that starts to take into account composite materials, isotropic, nonlinearity, dynamic pre-stresses, really going to cover the full gambit for what you'd be looking to run from a simulation perspective in that advanced simulate. So really depends on the type of use case that you want to be able to use it for. But with that, I can go ahead and jump into a quick demonstration so you can see what it looks like to use Simulate from within Creo. If you have any questions or anything that you want me to explain further around, feel free to drop that in the Q&A. But with that, I go ahead and switch over here into my Creo environment, and we can go ahead and jump into looking at our model. So we have an assembly here that I'm going to go ahead and use for this. It's held together by a metal frame, like you can see in the outside of this. And on that metal frame, you have some brackets in the corners that maybe we use to mount this over in the shop. And you may have used this bracket in a previous design, but you haven't used it necessarily in this particular context, and you need to make sure that it's going to work. So let's go ahead and use Simulate to do that. It's just available right up at the top. And you can see all the different tabs that you have here for laying out your loads, constraints, materials. It's all the same user interface as really anything else that you're going to do from within Creo. So first thing that we would likely do here is lay out some constraints for the model. In my case, I know the edges that we're working with here are going to be welded down. So this is maybe where we're going to go through and hold that part. And next we can go ahead and apply some loads. And in our particular case, our load's going to be on these holes where the attachments are going to go. And you can specify exactly how that's being laid out. If you want to do it as a total load, or you want to do it as a total load at a point that might be outside of where the surfaces are, you can give it a little bit more of a twisting or torsional force if you'd like to there as well. And whenever you go through and lay that out, you can get a preview of what that's actually going to do in the model itself. And that's looking pretty good. So after I've applied my loads and constraints, we can go ahead and just run through the study, right? And we really have a lot of different options whenever it comes to this. Your static, modal, buckling, fatigue. In this case, I want to apply just a static load so we can see what this looks like. And we'll use the constraints that we made. We'll use the loads that we laid out. And there's a couple different ways that you could do it. You can do it as a single pass study or a multi-pass. And essentially what that's going to do for you is allow you to get within a certain level of convergence or accuracy based on the number of different passes that it's going to run through. So it'll run through multiple different times of the study until it gets within a certain limit that you set for the study that you want to run. So maybe in this case here, let's go ahead and set this to 6% convergence. So we can go through and lower that down as you get further along in the design process, but you can really decide exactly the level of accuracy that you want to get back in terms of the results. And we just let that run through. And once the study is complete, we can go ahead and look at some of the results that we're getting back. You can see this comes up with a template. First gives me an animation for the displacement, different options for what you want to plot out on the part. So looking at what we're getting back here, we have stress value of about 19,000 PSI over on the left. We can see what we're getting back in terms of the displacement there in the middle. And just really looking to understand kind of where we're at, right? And I know just based on some of the results that we're getting back, it's probably going to be too much stress for my particular part. Might need to go back and make some changes here. So looking at this, I see some different things I could modify, maybe make it thicker, but maybe at the same time, I'm also concerned with the weight, and that would make the part too heavy. I'm going to avoid that. So instead, what we can do here is a sensitivity study. And what this is essentially doing is we're running that analysis, but whenever we run the analysis, we want to change something along with that. So I know based on my initial results that I had some high stress in that filleted region. So I'm going to see what happens as I change the radius there. And the difference really is, instead of me, the designer, having to iterate through values, I just tell Creo and let the system do it within a particular range that we set for it. And now we'll just go ahead and rerun back through the study here and see what we're going to get back in terms of these stress values. All right, so we're interested in seeing how the von Mises stress is changing. So I can see visually now, as I'm changing that fillet radius, what the resulting stress value is going to be. So I can see here to get to maybe around 11,000 PSI, we would need a radius of 0.4, so actually double what we had before. And then from there, we have options. I could go back into the part, I could change it, or I could just let the system give me the exact value for whatever my use case might be. And in this case, I don't want to just simply add material to this. I want to actually minimize on the mass of the part. So what we could do in that sense is do more of an optimization. And with an optimization, what you'll do is define certain limits for that optimization study. So like before, I know I can't have stress values above 11,000 PSI. So I can go ahead and get that added in here. We have different measures that we can work with here, either predefined or user-defined values that you can optimize around. So we'll go ahead and give that a value of 11,000. But you can have more than just one, right? Maybe I'm also kind of concerned with the bracket warping. So I want to put a range on the maximum displacement that we're going to work with here. So let's put it at 0.0015 inches. And now that I have a few limits that I don't want the study to exceed or what I want it to focus on, what I can do is add in some variables that the system can work with and use for this particular study. So we'll go ahead and give a range for that fillet size. So I could just have the system go right now, figure out what the optimal radius is that matches our limits. But you can see there's a lot of other things that we could utilize, right? We could tell the system to change the height, work with the width, the length of the bracket, the thickness, and working with all these different values and trying to figure out what is the best combination of all of these. If I was doing that manually, that's going to take hours, days to even figure out even a piece of what we're working with here. So the idea is that we don't have to take and use all that time. Instead, I just can work with the spreadsheet here that we have down at the bottom to type in certain bounds for the study. So I know how big a certain tab can be at the top, how big it can be at the bottom, what the width value might be here, just different values that I want to go through and set different parameters that I want to study, but I want the system to do all of the tedious work for me. So again, the overall process, just first, tell the system what your design goal is. In this case, it's going to be around minimizing the mass. Next, we tell the system the bound for the study, exactly how high or low each value can go with that. And then finally say what your dimensions or variables that the system can utilize in the study are, and to manually iterate through that and use that in your design would take just entirely too long to accomplish. That's why people typically wait until the end of the design process to even do this type of work. But we can see here now that Creo is going to go through and try out different designs, see if your design limits are satisfied. It's also checking to make sure you're either getting closer to or moving away from those limits and then changing the values accordingly. All right, and once you get within the value that we set for that, we're essentially done. And then we have our optimist part that we can look at here. So that's what we're viewing here is going to be the new design, and clearly it's going to be a lot different than what we had before. So you can see the fillet size seems to have increased, the tab size decreased, and at the same time reduce the mass as much as possible with that. And throughout that, we can go back and review some of the different steps that we actually took towards getting to that design. And we can see with each step here exactly what our study did and what Creo changed right on top of the model. So lower the tab height, maybe increase the fillet radius, just keep shrinking the part in terms of the mass, but at the same time maintaining all of the structural requirements that you need for the bracket. So regardless of what type of study that you're running, could be something like a structural study like you see here, or whether it's a thermal or vibration, the idea is that this is how you want to be doing it. It's while you're designing, it's while you're trying things out, and while you're working, just jump right over into Creo Simulate, throw your model through, and not just look to get a pass or fail out of the model, but really ultimately at the end of the day, look to get to the best model possible that goes just beyond some of the simple requirements that you might have laid out for it. So that really covers exactly what I wanted to go through and at least give you a walkthrough of the workflow of what it looks like to use Creo Simulate from within Creo. Again, you don't have to go through and work with a different software in order to do this. You can just write from within your own environment. And it's the tool that we've had in Creo for a long time for being able to do this. We've worked on it, we've refined it, we really add to it every single release of Creo still. But one thing I want to kind of cover here as well is the fact that we have a larger simulation portfolio that this plays a part in, and multiple different tools that have their own value. So I can go through and explain a little bit more so into the specific capabilities that go into each of these different simulation tools and really how it compares to Creo Simulate. And if you have any questions around this, feel free to drop that in. But I have a couple kind of breakdowns here. It's a little bit outdated. It's actually before our most recent release of Creo 10. So some of the different specific capabilities may or may not be involved in some of the different tools here. But first and foremost, if you ever heard of or worked with Creo Simulation Live, this is our real-time simulation capability that we have from ANSYS. It's something that we use early to mid stages into the design process, and really is very useful for I'd say improving the design, doing some level of optimization, but not as much of what you would do in terms of the final stage validation style analysis that you might get from something like Creo Simulate or another tool that I'm going to mention. So very, very useful in the earlier stages of the process, but not as much as you start to get towards the middle and late stages of the design. So you can see some of the different areas that it still covers for structural, thermal, modal. It's really just going to be your static, nothing dynamic or nothing going to be really outside of what you would do from a static linear perspective. And then as you start to move on from there, we have two main tools that we really work with from a standard type of finite element analysis perspective. You have Creo Simulate and you have Creo ANSYS Simulation. So Creo ANSYS Simulation is embedding the ANSYS workbench solvers from within Creo as well. And they covered a couple different areas. Again, Creo Simulate has been in Creo for a long time, right? Even before it was Creo, back when it was Pro Engineer, we had these different capabilities. So you can see some of the main areas that you're working with here. You have your Simulate and Simulate Advanced, and then you have Creo ANSYS and Creo ANSYS Advanced. So right now, the main difference is the fact that they use different meshing technologies, whereas Creo ANSYS uses an H-type element mesh. Creo Simulate will use a P-type element mesh, and a lot of overlap in terms of the standard type of capabilities that you're working with there. You can see that some of the features that would be available in Creo ANSYS are planned for some of the later versions of Creo ANSYS, and a little bit more of a breakdown here. Some of these things actually have been added into the tool, and if you're interested in to see exactly what Creo ANSYS includes and what types of capabilities that it currently has, we can definitely go through and get you some information around that. But really, Creo Simulate covers all these main areas that you see that are checked off. So that's really the main difference, is that Creo Simulate is a very mature tool. It has a lot of these capabilities available for you right now, but going forward into the future, we're going to be supporting both Simulate and Creo ANSYS Simulation as well. So definitely something to be aware of. Creo Simulate is definitely a strong tool right now, but you're going to see more and more capabilities with Creo ANSYS going into the future too. All right, so any questions that you have around that, feel free to drop those in. But with that, I can go ahead and pass it over to you, Rob.
Yeah, the question becomes, what simulation tool do I need? And that's where we come in. At 3HTI, we have I think one of the most foremost experts in simulation and analysis on our team. He's not just familiar with the tools in the PTC suite for Creo, but he's familiar with the Simulia suite from Dassault Systems, Abacus, Nastran. He's worked with many different simulation tools. He's worked on projects and has done training with NASA, with some of the government national laboratories. So to say this guy's really good is an understatement. He's amazing. So I mean, what we are able to do is help advise our customers, our clients, into, with simulation specifically, what tool is the best tool for the job. And the other thing is, sometimes you might not use simulation often, but just needed to run a simulation every once in a while, and you can use our services for analysis services to do that. Because a lot of times you may, the time it takes to get trained on the software for a couple of weeks, that might not be sufficient if you're only going to use it once a year, twice a year. If this is something that's ongoing, it may make more sense. So we're really good at advising our customers where it makes sense and helping you to determine, do we buy the solution, or do we allow 3HTI to do the analysis for us? And sometimes there's a hybrid. Sometimes there's, okay, we're going to do this, the solution for you, but we'll work alongside of your people in the process to make sure that this is, work a little closely to make sure this is exactly what you need, and to help you understand more and gain more insight, not only to the tool, but to your product with the analysis and everything. So if you want to learn more about our simulation services or anything more about the simulation software from the PTC suite, respond to the email that I sent, for this webinar, they come directly to me. So we're more than happy to help. So I want to thank you, Paul, for your help today. Thank everyone for being on. Have a great rest of your week. And there will be, we won't have a webinar next week, but the following week. So keep your eye out for the next webinar. Thanks, everyone. Take care.